Good afternoon. We are going to be working on lesson 4.4. We're not covering lesson 4.2 and 4.3. 4.4 is all about crunching the numbers. These are the problems that we're going to be doing. And our quote says, errors used in inadequate data are much less than those using no data at all. But we really want to have good data. Don't just want data, but you really want to have good data. So let's get started down here. So as we begin our study of statistics, it would seem reasonable to have a really good idea of what they actually mean. Statistics is a branch of all math that involves collecting, organizing, summarizing, and presenting data and drawing general conclusions from those data. If we're talking about grade inflation, then relevant data might be average grade point averages for students in several different years. This table below shows GPA data from the website gradeinflation.com. So between 1983 and 2013, this is the average undergraduate GPA. So average GPA of all students in post high school. So it does look like it's been increasing. I wonder why. In statistics, we start with a question we'd like to answer, like, is grade inflation a real phenomenon? Inflation means it's going up artificially. So a fake increase is kind of meaning that it's not that people are getting really much smarter. It's just maybe we're giving students grades they don't deserve. Maybe there's ways for students to earn, especially in high school, earn higher and higher grades. Higher than a 4-point, then we gather data and try to interpret them in order to answer that question. So write a verbal description of the information provided in the table. Do you think it supports the idea of grade inflation? So it appears that undergraduate GPAs have increased steadily from 1983 to 2013. So that's 30 years. How do you think these numbers were calculated? What students' GPAs were considered? So could it be an average of colleges? We don't know if they're 2-year colleges, 4-year technical schools. We're not really sure how this is calculated, right? So these are good questions. How did they get the data? So the ideal way to gather GPA data would be to add the GPAs of every college student in America during each year, then divide by the number of students. Needless to say, that's not particularly realistic. Aside from legal ramifications, like you can't just ask somebody their GPA, in any given year, there are more than 20 million students enrolled in American colleges. And by the time all of that GPA data were gathered and recorded, many of them would be contemplating retirement, as in it would take a long time. So instead of GPA data are obtained from a sample of college students. So a population consists of all subjects under study. And please always give me that description with an all for the population. A sample is a representative subgroup or subset of a population. In the case of the GPA data we've been studying, the population is all undergraduate students GPA. The sample is the students GPA in the study. And they didn't even tell us. Usually the sample, they will tell us how many, but they did not here. In this case, GPA data from a sample of 70 colleges, well, there you go, they told us 70 different colleges were used to compute the average. The thing that makes the data compelling is that the sample is representative of the population as a whole. The schools chosen vary in size, cost, geographic location. Some are public and some are private. So that's important. Discuss what exactly is meant by a representative sample and why it's so important in answering questions using statistics. So representative being not all high scoring students. A good mix of all races would be important. A mix of locations would be important. Private and public schools, there's different education at those. So it's important that everybody's represented, or else you're really only given an average of a particular type of student. So we will study 4 basic sampling methods that can be used to obtain a representative sample: a random sampling, systematic sampling, stratified, and cluster. In order to obtain a random sample, every subject of the population has to have an equal chance of being selected. The best way to obtain a random sample is to use a list of random numbers. These can be generated from a variety of internet sources or from a computer calculator. Subjects in the population are numbered, and then the ones to be studied are picked by using the corresponding random numbers. If you were going to do a survey with every student at your campus as the population, describe how you might obtain a random sample to survey. More specific is better. So we want to make sure everybody's possible, right? So we would maybe want to have a list of all student, let's say, IDs, because those are unique to each student. Okay. Use a number generator, a random number generator, to choose which students in the sample. That's important. Okay. A systematic sample is taken by numbering each member of the population and then selecting every kth member, where k is some natural number. For example, the researcher from gradeinflation.com might have numbered all of the colleges willing to release grade information and chose every 10th one. In this case, k equals 10. When using systematic sampling, it's important that the starting number is chosen randomly as well. So let's go back to the campus survey mentioned in question 6. Describe how you might develop a systematic sample. So list all students. You could list them in alphabetical order. That is ordering them, at least, alphabetical order. Then choose random number between 1 and 20 to start. Then choose every, we'll say 20th student. And there's more sophisticated ways and reasons why you would maybe choose between 1 and 20 or every 20th student. If you want more students in the sample, you would go a smaller number, like every 10th student. If you want fewer students, you would go maybe higher, like every 50th student. When the population is divided into groups, where the members of each group has similar characteristics, like large public schools, large private schools, small public schools, small private schools, and a certain number of members from each group are chosen at random, the result is called a stratified sample. For example, the grade inflation researcher might have decided to choose 5 schools from each of those groups. Medical researchers often stratify samples by dividing subjects into gender groups, age groups, racial groups, or many other categories. They would then randomly choose a similar number of subjects from each group to compose the stratified sample. Describe how you'd put together a stratified sample for that campus survey we've been talking about. Okay, so we could separate students, I know, by pathway. So the pathway that you've chosen at Jackson College, and then take a random sample from each pathway. And the reason I say that is because when you choose a pathway to study at Jackson College, the those students in those pathways have similar interests, and so you're kind of getting a little bit from each student group at Jackson College. Okay. When an existing group of subjects that represent the population is used for a sample, it is called a cluster sample. For example, suppose we were interested in studying hunger in Ohio. There are 88 countries in the state, so 88 counties in the state. So we could randomly pick a dozen of those counties. We could then choose a random sample of cities in each selected county to gather data on the number of food insecure families in those cities. In the case of the Great Inflation Study, researchers might look for existing groups that colleges fall into. There are several different organizations that provide accreditation to colleges in the US. If a couple of those organizations were chosen randomly, then schools from each of those groups could be surveyed for GPA data. The accreditation organizations would be the clusters. It can be a little tricky to distinguish between stratified and cluster samples, so you might find it helpful to think of it this way. If the entire population is divided into distinct categories and some subjects are chosen from each category, that's stratified. If the subjects are chosen from just a small handful of existing groups, that's a cluster sample. So describe how you might develop a cluster sample for our campus. Okay. So psychology classes, because it seems like that's one of those classes, or English classes, that all students take. So we could pick English, maybe 131 courses, and randomly choose different sections. So that would be a particular course on a particular day, different sections to sample all students in those sections. So I also like to think of the difference between cluster and stratified as kind of this idea that stratified is like taking a layered cake and slicing the layered cake, and that way you're getting like a little bit of each part of the layer in the cake. That's stratified. You're getting a little smidge of each flavoring in the cake. Now cluster would be like, I'm just going to eat the icing, and I'm going to eat just the icing on all three layers. So a cluster is you're taking all from different pieces, and a stratified is you're taking a sliver and you're getting a little bit from each piece. Okay, so let's go back to the notes. Number 10 here. Think about 4 different sampling methods the researcher from greatinflation.com could have used. For questions 10 through 13, write which of the sampling methods we've studied was used for each situation. Explain your choice. So the researcher randomly selected 3 states and then asked all colleges willing to release grade information from those states. So that would be a cluster, because each state would be, or actually should be, representative of the population. And then asked all, and then they asked all of the colleges within those states. The researcher numbered all the colleges willing to release grade information and chose every 10th one. So every 10th one means it's systematic. Number 12 says the researcher numbered all the colleges willing to release grade information and chose several of them using a random number generator. This would be what we call the random sample. And this, you can see, is the lesson check for lesson 4.4. The researcher grouped the schools by 2-year schools, 4-year schools, 2-year private schools, and 4-year private schools. The researcher then decided to choose 5 schools from each of those groups. So this would be stratified. They broke them into groupings that were similar, 2-year, 4-year, 2-year private, 4-year private, and then took a little bit of each. Okay. Rank the 4 sampling methods in questions 10 through 13 from best to worst in terms of how representative you think the sample would be. Explain your rankings. So I definitely think the random is probably the best. I think the systematic is probably the worst, and not that it's bad. It's just you don't know when you number them or whatever, all of the ones that are private could be in a chunk, or all the ones that are public could be in a chunk. So you might not be getting a full random sample. Between number 2 and 3, I think the stratified is good, because that way you know you're getting some from each grouping that you want. The clusters may not be representative from the whole population, especially up here of population. Oops. Where we did the cluster, they only chose 3 states. That's kind of scary. Now, maybe if they said they chose 15 states out of the 50 and then chose colleges and sampled everybody from within there, I think that'd be better, but I'm not sure 3 states would be enough. So that is all for part 1 of lesson 4.4. Catch me back, and we're going to look into what we do with the data once we get it.